Uh, Welcome each and everyone present over here. Ma'am, should I start? Hello, hello, hello. Should I start? Okay. Welcome everyone present over here. This is Umakant Srivastav, PhD research scholar of Dr. C. Raman University in, in physics. I am here to present my PhD summary presentation entitled Preparation of Eco-Friendly and Low-Cost Fly-Ash-Based Materials for Various Application. I have completed this work under the esteemed supervision of Dr. mzkhan sir. Now moving toward the presentation, initially I would like to introduce to the contents of research work I would deliver today. Those are introduction, literature review, methodology, study and preparation of eco-friendly and low-cost fly ash bricks, thermoluminescence behavior of fly ash when mixed with composite material, PL study of fly ash when mixed with composite material, result and discussion and conclusion. Now coming toward the introduction part of the title itself, we can have an idea that our material of interest is coal fly ash generated from various thermal power plants. In thermal power plants, during combustion, the volatile matter and the carbon is burnt off, but the coal impurities such as clay, shale, quartz, and feldspar mostly fuse and remain in suspension. These fused particles are passed along with the flue gas. As the flue gas approaches the low temperature zone, the fused substance coagulate to form mainly spherical particles known as fly ash. Some of the properties of fly ash are given below, as it is a fine powdery particle of shape ranging of spherical shape ranging from 10 to 100 micron size. It is glassy in nature. Its fineness ranges from 3000 to 6000 square centimeter per gram, and its color varies from tan to gray to black. It can be classified into different types depending on the types of coal, like bituminous coal, subbituminous coal, and lignite coal. And its composition comprises of silicon oxide, aluminum oxide, ferrous oxide, calcium oxide, magnesium oxide, and so many other compounds. Uh, since we are concerned with the utilization of fly ash by preparation of application-based materials, from last 2 decades, we are trying to use it in all possible application, like in construction of bricks and in construction of concrete, along with the construction of road. But we are unable to attain its 100% utilization and achieved around 60% utilization of its whole generation, because it's a resource material unless we use it in any other application. Rather than, it is a global pollutant which can cause several hazardous health issues and causing waste management issues globally. Thus, its 100% utilization is our main aim. The objectives of my research are divided into two parts. First, the preparation of eco-friendly and low-cost improvised fly-based materials for building construction application. Under this objective, we have prepared brick samples with the inclusion of lime and additives like rice husk, eggshell, neem leaf powder, and tulsi leaf powder. Those are medicinal plants. To test and second, to test the behavior of fly ash when combined with composites. Under this objective, we are testing luminescence properties, both TL and PL properties of fly ash mixed with phosphor materials for radiation dosimetric application. In the chapter 2, we have concerned with the impactful reviews taken for this work, and these are the reviews from the year 2001 to 2021. Now, in the next chapter, that is methodology, we have discussed about the various methods for performing our two objectives. In the first objective, we have taken air-cured method for preparation of eco-friendly bricks, while in the second objective, we have used solid-state reaction methods for testing fly ash behavior with the composite phosphor. In air-cured method, initially we collect the fly ash samples and prepare mixed design of the raw material. and then the homogeneous mixing of the materials are done. Then the homogeneous mixture of the material are taken into the mold for settling. The formation of micro brick samples at high pressure with the help of KBR pellet is done. Then the prepared samples are dried and stacked for 2 days, at least 2 days, for air cured using air cured method. The curing of these samples can be done are done at different ages of 7 days, 14 days, 28 days, and 45 days. And finally, the testing of compressive strength, water absorption, and efflorescence of these materials are taken with the along with structural analysis. For the second objective, we have taken solid state reaction method. In this method, again, we have collected the raw material of fly ash, and we have prepared phosphor with the addition of Teflon in calcium sulfate diphosphor at 3:1 ratio. And we have prepared mixed designs of fly ash and phosphor. Mixing of fly ash in prepared phosphor and put powder for 4-hour calcination is done. Then we prepare discs of 13.75 millimeter thickness, and then those discs were exposed to irradiation of low and high dose. Finally, after the preparation and the exposure of discs, TL and PL studies are taken for optical properties of studies. And finally, the XRD and SEM are taken for structural, morphological, and mineralogical studies. Now moving toward the chapter 4, that is the study and preparation of eco-friendly and low-cost fly ash bricks. In this chapter, we have discussed about the studies taken for preparation of fly ash bricks, and for that we have prepared 5 different mixed designs and named them S0, S1, S2, S3, and S4, and the compositions are given in the table. Using these mixed designs, we have prepared the mixture using at different pressures of 1 ton, 2 ton, 3 ton, 4 ton, 5 ton, and 10 ton. By applied these pressures are applied by KBR pellet machines for casting. The properties like compressive strength, water absorption, and efflorescence were tested along with the XRD and SEM characterization. Compressive strength of the material of the big sample is tested by dark system inclined universal testing machine, and it has been calculated with the help of the formula Fc is equals to P by A in Newton square or MPa, megapascal, where P is the maximum peak load and N is the net cross-sectional area in square millimeter. For water absorption calculation, we have used the formula given in the water absorption column, where in which M2 minus M1 by M1 into 100, where M2 is the mass of brick within 3 minutes after sample has been removed from water, and M1 is the mass of air dried sample at room temperature. The third parameter we have calculated is the efflorescence, and it has been categorized in 5 different categories. Those are nil, slight, moderate, heavy, and serious efflorescence. When there is no deposition of salt around the brick's surface, then it is under nil category. Then if less than 10% salt deposition is there, then it is slight category. Under the moderate category, the deposition is up to 50% of the exposed area. When 50% or more deposition is there, then the efflorescence is categorized as heavy. And when the powdering or flaking of the exposed surface is occurring, then it is serious kind of efflorescence. For all these samples, we have calculated compressive strength of the at different curing edges. At 7, in the first table, we have compressive strength at the age of 7 days. In the second table, we have calculated the strength at the age of 14 days. Similarly, in the third table, we have calculated this compressive strength at 28 days and 45 days. And after the calculation, we found that FALRH sample of brick shows the highest compressive strength of 9.177 MPa. Similarly, we have calculated the water absorption capacity of samples in different curing ages of 7, 14, 28, and 45 days. And the same sample of FALRH, that is the composition of fly ash, lime, and rice husk, shows the lowest water absorption capacity, which is required for suitable in construction application. Efflorescence of the big samples FALES, FALRH, FAL, FALTLP, and FALNLP are taken, and FALRH shows the uh, better efflorescence than other big samples. The XRD uh, X-ray diffraction study of the brick samples is taken with the help of pan analytical 3 kilowatt expert XRD machine, and the same analysis is done using SAM 3069, which is having tungsten filament. In the chapter 5, we have to study the thermoluminescence behavior of fly ash when mixed with composite material. Thermoluminescence does not mean temperature radiation, but enhancement of light emission of materials already excited electronically by the application of heat. In this chapter, we have investigated the behavior of fly ash when mixed with composite materials like phosphor. We have used calcium sulfate dy phosphor, and the phosphor is mixed with the fly ash in various ratios, and the ratios are given in the table. We have 5 different compositions: pure phosphor, pure fly ash, phosphor plus 10% fly ash, phosphor plus 20% fly ash, and phosphor plus 30% fly ash. And these are the name of those samples. And these are the prepared samples, like the disk we have prepared uh, for TL characterization and PL characterization. So P plus Fa10, P plus 20, P plus 30, Fa30. PP means pure phosphor, and PFA, that is pure fly ash. And they initially they have been exposed to low dose of cesium 137 exposure, up to from 1000 mr, 2000 mr, 3000 mr to 4000 mr, and at high dose electron beam by Clinic 6, Clinic 4 IX, it has been exposed to 1000 CGY, 5000 CGY, 10,000 CGY, and 20,000 CGY. Uh, this is the setup of thermoluminescence reader nucleonics TL10091, from which we have taken the TL study of the desired phosphor. The study of TL kinetic parameter like frequency factor, order of kinetics, activation energy, lifetime of peak are also performed and calculated using using some methods like Chen's peak shape method, initial rise method, glow curve deconvolution method, and 3-point analysis method, etc. In the chapter 6, we have studied the photoluminescence behavior of fly ash when mixed with composite material. Photoluminescence is basically the phenomena when light of sufficient energy is incident on the material, photons are absorbed, and electronically excitations are created. So the study of PL is taken with the help of RF 5301 PC spectrofluorophotometer. Finally, in the result and discussion chapter, we deals with the result and the analysis obtained on the basis of structural, morphological, mechanical, and optical properties of the materials, sustaining objectives in chapter 4, 5, and 6. In the chapter 4, we have calculated the compressive strength of the brick samples, and here we have plotted, we are showing the plot of compressive strength versus curing age at different casting pressures of 1 ton, 2 ton, 3 ton, 4 ton, 5 ton, and 10 ton. And we observed that highest casting pressure of 10 ton shows the highest compressive strength in all the cases, in cases of all the brick samples. And we have also taken the water absorption versus curing age graph, and we have observed that at the at 10 ton pressure or casting pressure, we observe the lowest water absorption capacity, which is required because water absorption and uh, compressive strength are inversely proportional to each other in case of brick preparation. These are the same analysis, same graph of FALES sample and XRD uh, plot of the same material at the same analysis are taken at 200 magnification, 500 magnification, and 1000 magnification, and we can see the materials are very well coagulated with each other. All the components are very well coagulated with each other. Similarly, in case of FALRH, we can see here that the fine particles of fly ash, lime, and rice husk are very well coagulated with each other, and they have uh, confirmed the hexagonal cubic structure with the help of this XRD picture. And the existence of quartz Al2O3 and CaO is also confirmed with the hexagonal cubic structure. Similarly, for FAL sample, we have given we have shown the same pictures, same images of 100 magnification, 200 magnification, and 2000 magnification, and it is very well matched and very well coagulated with each other. For FA and L NLP sample, we can clearly see at 200 magnification, at 500 magnification, and 1000 magnification of same images shows very well coagulation of the components, and the XRD images shows highest peak intensity up to 500 intensity with respect to 2 theta value, and similar for FAL TLP value. Now, in chapters 5, the thermoluminescence study of phosphor material prepared by mixing Fa are displayed below at different doses. At low dose, we have uh, observed that the green colored glow curve of Fa10 P plus Fa10 sample is quite in analogy with the pure phosphor sample, and it remains consistent in all the doses. Thus, it is suitable for the dosimetric application. Also, in high dose case, at 1000 CGY, 5000 CGY, 10,000 CGY, and 20,000 CGY, the green colored Fa10 sample again shows quite analogical glow curves with respect to other samples, and especially with respect to uh, pure phosphor sample, which confirmed that this Fa 10 sample is suitable for dosimetric application. And this is the same analysis of pure fly ash sample, in which we can confirm the spherical shape of fly ash at 500 and 1000 magnification clearly, and the highest intensity of pure fly ash ranging between 5000 to 6000 intensity value, and it confirms hexagonal cubic structure. And the same images of calcium sulfate dy plus Fa10 sample, which is suitable for dosimetric application, clearly shows that these uh, white structure in the whole surface, and you can see it is a shape like trap, which basically traps the energy given or provided it through the thermal excitation. We have also calculated the TL kinetic parameter for 10% fly ash mix sample, that is calcium sulfate dy plus Fa10 sample, with the help of glow curve deconvolution method, initial rise method, chance peak method, and we have observed clearly well matched activation energy like 0.42, 0.36, and 0.63, and all other TL kinetic parameters. The photoluminescence study of the phosphor material prepared by mixing Fa are displayed in the two pictures below. The excitation plot itself shows that the Fa10 sample shows the highest PL intensity as well in the range between 320 nanometer to 400 nanometer wavelength, and it also shows the emission plot between 475 nanometer to 625 nanometer wavelength range. Now coming toward the cost efficiency of these two samples prepared, eco-friendly bricks and this TLD dosimeter, the we have prepared each a single price of bricks in a very low cost like 2.7576 Indian rupee, and which is quite low in comparison to other brick samples. And FA10 TLD is being prepared in around 100 to 110 INR, which is also quite low in comparison to other TLD prepared. Now coming toward the conclusion part of the work, it has been concluded that the eco-friendly brick samples prepared were having average compressive strength in increasing order as S2, S0, S1, S4, and S3 shows higher than traditional clay bricks and analogous to fly ash bricks. Water holding capacity of good compressive strength reported samples have been estimated below 12%, which is necessary for fly ash bricks. Above samples does not show that much efflorescence, thus suitable for construction application. XRD graph confirmed the presence of hexagonal crystal structure and remains in analogy with the concerned JCPDS cards. Further, it has been obtained that the for the next objective for low dose exposure at 100, 1000, 2000, 3000, and 4000 MR by by cesium 137 gamma irradiation, phosphor Fa plus 10% material shows linear TL response curve and proper TL intensity versus temperature curve, which makes it suitable for dosimetric application. At high dose exposure, again at 1000, 5000, 10,000, and 20,000 centigrade by high energy 6 MeV electron beam phosphor mixed with 10% fly ash shows linear TL response curve and proper TL intensity versus temperature makes suitable for dosimetric application at high dose. The linearity graph confirmed the linear dose response along with the estimation of kinetic parameter also confirmed the good TL response of sample prepared. It has been found also that the PL intensity peaks of emission varies between 475 nanometer to 625 nanometer wavelength range, while the excitation spectra ranging between 320 nanometer to 400 nanometer wavelength range. Our future perspectives of this work is that it will be boon for researchers of civil and architectural engineering for and also for medical physicists. It will be strengthened in waste management in the field of construction, radiation measurement, and new technology. Some of the future prospects are it can be used in radiation measuring equipments with different phosphor composite and radiation sources. Use of fly ash in paint application. We can use fly ash in agriculture as soil amelioration agent, and it can be when strengthen the well waste management concept in construction industries apart from bricks. These are the references I have taken, and the list of the research paper. These are the first pages of all the research papers I have published, and these are the paper presented in the conferences. These are the certificates. I have gone through several testing agencies for testing and for testing of my samples, and the fly ash collection site is NTPC Sipat, NTPC Korba, and Akaltara. For TL characteristic, I have taken help from SOS in physics of Pandit Ravi Shankar Shukla University. XRD I have taken from NIT Raipur. PL again I have taken from Ravi Shankar University Raipur. For compressive test, CPET Raipur and Civil Engineering Department of CVRU helped me a lot. Water absorption is done using with the help of Civil Engineering and Chemistry Department of CVRU. Uh, Scanning electron microscopy I have done from Kalinga University Raipur at low dose exposure, and all the TLD manufacturing process has been done at Ultratech Laboratories Bhilai, and a high dose exposure of these discs were taken at the Department of Radiotherapy, Apollo Hospitals, Bilaspur. these are the some pictures of the whole work I have taken. Thank you.
Very good, Umakant sir. Beautiful and excellent presentation, as well as your presentation of the slides are also very beautiful,
Thank you
stepwise.
so much,
Very
ma'am.
nice presentation. The sequencing is also very nice.
Thank you, ma'am.
I would like to request the research cell as well as the dean to make the scholars follow this kind of presentation and preparation of the slides in a sequential manner. It would be
Yes,
better for the scholars to go with the instructions like this. He has mentioned the areas of the testing agencies also and testing spots and points also. So that should be mentioned and prepared in the slide. Chapterization also.
yes,
Very
ma'am.
really appreciable. Appreciable. Very nice.
Thank you, ma'am. Thank you so much.
Any other suggestion from department side? Srivastava sir, आप mute
Srivastava,
हैं.
you're not audible.
हाँ. Any suggestion and query from my colleagues? Already it is excellent presentation. Thank you, madam. Congratulations to especially Dr. Khan sir, Dr. Umakant sir, Dr. Pandey sir, all my teams, Pandey sir, Vikas sir, Umakant sir, to
Thank you, sir.
assisting, promoting the research such type of. A lot of thanks, the hearty congratulations.
Thank you,
Thank
sir.
you, thank you, thank
Okay,
you,
thank you
thanks,
very much to all of you.
thank you.
Thank you.
अब
Congratulations, sir.
This is the perhaps
Thank you.
this is the role model of presentation. Already
Yeah,
our
it can
team,
be introduced as a sample, sir. It can be introduced to other scholars as a sample. The sequence is very nice, so it can be
जी,
introduced by the research cell as well as by the dean to the scholars of your own faculty. This must
okay
be
madam,
kept in mind by the dean of the science faculty. You can introduce as a sample to all the scholars of the science faculty.
okay, thank you madam,
Thank
thank
you.
you, thank you,
Thank you all.
thank you.
सर आज का सेशन क्लोज करते हैं उमाकांत सर आप
जी.
अटेंडिंग करा के
सॉरी मैम, आवाज़ नहीं आ रही आपकी.
प्लीज सीसी से दिए आर्टिकल में सबमिट जल्दी
खान
से
सर,
जल्दी
हाँ सर,
आपको बहुत बहुत बधाई आपको.
थैंक यू। ये सब टीम वर्क है सर अपना।
हाँ, हमारे डिपार्टमेंटल रिसर्च कोऑर्डिनेटर पांडे सर को, जितने भी टीम हैं, सबका मोरल सपोर्ट कि आज हम लोग एक मॉडल ग्रुप में हो गए, जिसके सुपरवाइजर आप हैं. बहुत बहुत हृदय से बधाई सभी को. अमृता मैडम को भी स्पेशली बधाई. पूरे पीएचडी सेल को बधाई. थैंक यू,
सर आज का सेशन हम क्लोज कर रहे हैं थैंक यू टू
थैंक
ऑल
यू.
ऑफ
ओके ओके.
ओके, थैंक यू वेरी मच।